Good afternoon, everyone. Today we're going to factor a difference of squares with two different examples. So for the first one, we have y is equal to x squared minus a1. And these are more straightforward because we have a leading coefficient of 1. And you can imagine this is really the same thing as y is equal to x squared plus 0x minus a1, right? Because that middle term is absent, it's the same as if it had an x coefficient of 0, right? So you can use a similar strategy that we use to factor, namely thinking of two numbers that simultaneously add to make that x coefficient. So add to make 0 and multiply to make negative 81. That might be easy to come up with. The numbers that add to make 0 and multiply to make negative 81 are negative 9 and positive 9, right? So you can factor the way you always have. But in making that connection to something that you've already hopefully built some confidence with, anytime we have a difference of squares, that is to say whenever we are purely subtracting some perfect square and another perfect square, the result is the square root of the first term. So the square root of x squared is x. So we have an x here and an x there. And the square root of 81 is 9. So we have plus 9 in the first bracket, minus 9 in the second bracket. And that's it. Now, those of course are interchangeable, right? Because the order doesn't matter. You could equivalently write it as x minus 9, x plus 9. We're not concerned with the order when we multiply two factors together. But it's just that idea, whenever we have a difference of perfect squares, we can go right down to its two factors by the square root of the first plus the square root of the second times the square root of the first minus the square root of the second, okay? So applying that same kind of logic to this slightly messier looking one, again, you might have some other strategy that applies more generally, but if you recognize that these are two perfect squares that are being subtracted from one another, we have a difference, subtraction of squares, and so we can factor them right away as the square root of the first term. The square root of 16x to the 4 is going to be 4x squared. So that's going to be the first part of each factor. We're going to add in the first one and we're going to subtract the second factor. And the square root of 36y to the power of 6 is, the square root of 36 is 6. And the square root of y to the 6 is y to the 3, right? If you have any issue visualizing why that is, just imagine multiplying y cubed times itself. When we multiply the same base, we add the exponents, so y cubed times itself makes y to the 6, right? So that means that y cubed squared is equal to y to the 6, which means that y cubed is the square root of y to the 6, right? So we get 4x squared plus 6y cubed and 4x squared minus, again, 6y cubed. And we're done, okay? These are our two factors. So this can be helpful, again, only in very, very specific circumstances. When we have a difference of two perfect squares, obviously that does not come up all the time or even every day, but when it does come up, this is a really, really quick and efficient strategy to factor it quickly, okay? Hope this helps. Thanks for watching. Take care.